To start the OntoConto plugin, click the action item called Visualize Context through Alignments in the toolbar. The first thing you'll see is the main OntoConto application interface, which we can maximize in order to see details more clearly. On the left side of the screen, it's possible to load an ontology in order to work on it. We can do this by selecting it in this Select menu. For the purposes of this demonstration, we'll select iolight.owl from the ontologies list. We then click Load, and the ontology is visualized on the left portion of the screen. Look more closely and you can see that these notes represent the concepts in an ontology, and the links represent a subconcept of relation in each case. In this way, we can connect all of the ontology and we can navigate through this visualization by clicking on any concept. For example, by clicking Physical Object, we'll get all the concepts of a physical object, as well as all of its sub-concepts. To actually show the alignment, we must select an appropriate item from the Please Choose Context Ontology drop-down menu. Once you've loaded the context ontology, the user interface changes, and you're now able to access new alignments by clicking the New button. Or you can select either Request Alignment with Local Methods or Request Alignment with Online Methods from the Alignment Server. To begin with, let's perform a simple task by requesting an alignment in which all the requests have an equal name. It's quite common to have to wait whilst the system calculates alignments, especially if ontologies are big or if the actual algorithm is time-consuming. Here you can see that there's just one mapping, and if we take a closer look, we can see what it is that it's actually proposing. In this case, it proposes that the concept, place, in the left ontology, which is itself a subconcept of social object, is in fact aligned with a concept place, which is a top concept in the context ontology. An ontology engineer who's using this visualization tool in order to extend the ontology is immediately provided with a neighbourhood of concepts, which can, in themselves, be good candidates, since they're used in the context ontology and can be taken into account in some other way in the original ontology. Apart from requesting alignments from local services, we can also request them from an online alignment server. This offers more options for automatic alignment, some of which can be quite time-consuming. It's also possible for the alignment engineer to add alignments to existing alignments. We can, for example, click on any existing alignment and change its measure of probability. We can make this mapping a bit less confident. We can confirm any changes and note that the colour of the mapping changes to reflect its probability. Apart from this, it's also possible to actually move the alignment if, for example, one place is wrong. We can also delete the mapping altogether. We can create new mappings by pressing M on the keyboard. We can click on any concept from one ontology to another and inspect the new alignment. We can also confirm the change and save the alignment, so let's do that by giving it a file name. In this case, Test Alignment, and clicking Save. The alignment is now saved, and we can safely close the OntoConto plugin. And we can even exit the NeOn Toolkit itself. The alignment is now stored on the alignment server, from where it can be accessed by any installation of the NeOn Toolkit. This makes it an excellent tool for the collaborative editing of ontology alignments. To see it again, simply restart OntoConto. You can see here that we now have a test alignment ready to load. Whilst we load it, the actual alignment is again visible in the editing area. And that brings us to the end of this demonstration of the OntoConto plugin for the NeOn Toolkit.